Hey guys, welcome to my YouTube channel. Today in this video, I'm gonna attack the concept of polynomials of 9th standard. So, polynomials. First of all, let us understand the difference between the polynomials and algebraic expression. Algebraic expression and polynomials are get differed by just one thing, that is degree. For example, let me write the thing. So, here, this first example is of polynomial, but of second example, it is algebraic expression. Now you only tell, what is the difference between these two? The difference is just one, that the degree of here of one term is in negative, and here every term is of whole number. So, the first condition for an expression to be a polynomial is the degree. The degree of each and every term should be in whole number. For example, if I write this is a polynomial, but if I write now this is algebraic expression. So the first condition to learn the polynomials is to attack the basics, and the basic is the degree of polynomial should be always whole number. Now, let us understand the different types of polynomial. Polynomials can be of monomial, binomial, trinomial, and the polynomial is the highest one. So, monomial is the polynomial containing only one term, like x or 1. 1 is also a polynomial because here it is 1 into x raised to 0. So, x raised to 0 is equal to 1 into 1 is equal to 1. So, remember this thing, that if a constant is given and it is asked that whether it is a polynomial or not, then you have to answer yes it is, because the degree of x is also a whole number, that is 0. So it is also a main thing. Now binomial means with two terms like x plus 1, y plus 2, like that. Trinomials consist of three terms like x square plus x plus 1, x square plus 2x plus 3, like that. These are the trinomials. Then quadrinomials are of 4 digits, like these are the quadrinomials, and polynomials can be of number of terms. Now let's divide the polynomial on the basis of their degrees. On the basis of their degrees, there could be, first of all, quadratic in greater than 1, degrees greater than 1, because the 1 degree is known as linear polynomial, that is simple like x, y and etc. The quadratic polynomials means the highest degree of that polynomial should be 2. For example, I took one, that x square plus x plus 1, here the highest degree is 2. But remember one thing, that x cube plus x square plus x plus 1 is not a quadratic because the highest degree is 3. So, for being a quadratic polynomial, the highest degree of that equation should be 2. Now, this one is example of cubic because the highest degree is 3. Then the next would be of biquadratic, that is of degree 4, like this. This is the at most level where you can understand the 9th level. So we will not go further. Then it can be like pentadegree, hexadegree, like that, but we will not go to further. Now, have you noticed one thing in this quadratic, cubic and biquadratic, that the terms, each term which is going backward is reducing degree by 1. Like see here 4, then 4 minus 1 3, like 2, then here it is 1, and then it is 0. So we can write that if a polynomial has degree n, if n is equal to degree, then we can write that polynomial can be expressed in form of So Here many students get confused that why n is taken. N is not here for multiplying with a. An is given that it is the nth term. For example, if n equals here, n equals 3, then it would be a3 x cube plus a n minus 1, it is 2, and x square plus ax plus a. Now here a3 just denotes that it is the third term, or the constant or the coefficient of the third x, that is x cube. A2 denotes that it is the coefficient of x square, or the second term. So we have to not get confused by seeing this n, because many students get fear by seeing this much long, but it is not like that. The last second term would be a1 and x raised to 1. So it would be ax, and at the last it will be a into x raised to 0. Then it would be resulting a. Let me revise it again, that n is the degree here, and if n equals to any number, then this n would equal degree, and this would denote the number of the term. That is, if it equals 4, then it would be here a4 x raised to 4. Means that this is the fourth term, like that. Now I will not explain here the remainder theorem, because it is already explained in one of my videos. So you can click on the I button and go there and see the remainder theorem. Now let's solve some sums regarding to this. So let's take exercise 2.1. The question 1. It gives us that which of the following expressions are polynomial in one variable. So here two things we have to remember, that the question has asked polynomial in one variable. One variable means that if expression starts with x, then the expressions between the first and the last term, there should be only x's, not y, z or any other variable. So let's see the first question. First question is 4x square minus 3x plus 7. Now here see, both conditions get satisfied. Or it is a polynomial because all the degrees are in whole number, and it is also an expression in one variable. Therefore answer to it would be yes. I will not do all the sums, but I will just pick out one or two. Now let's see fourth one. Fourth one, it is y plus 2 by y. Now it is not a polynomial, because here this y has degree 1, but when it goes upside it will result in 2y minus 1. You have learned this in first chapter itself, number system. See the last concept of the number system, then you will understand this one. Now let's take the last sum of this, which is x raised to 10 plus y raised to 3 plus t raised to 50. Now here the conditions get satisfied that these degrees are in whole number, but the variables are different. Therefore this is also not a polynomial. Okay, so let me revise it. Start. It is not a polynomial in one variable. It is a polynomial by condition that the degree is whole number, but according to the question, it is not in one variable. So let me revise that in this one all the conditions get satisfied. In second one, degree is not in whole number, and in third one that we saw here the variables are different. I think you might be knowing that what are the variables and constant, but if you not, let me just tell you that constant are the whole numbers or the integers, that is, or any real numbers. Let me tell you the real numbers, that is any number taken from the number line, and the variables are any alphabets, that is x, y, z or anything of which the value is fixed in the first only one expression. It changes in different equations. Okay, so now as I told you, the remainder theorem is already explained, but I will just revise it here and do sums of it also. So remainder theorem states that if any polynomial fx is divided by x minus a, then the remainder for it would be FA. Now if you want to see the proof, then please visit my video, and now I am just writing this and not showing you the proof. So what is fx here? Fx is just a denotation for a polynomial, and a here is any whole number, integer or anything. So let's do the sum regarding this. See, I am going to exercise 2.3 because in exercise 2.2 it is only given to substitute the value of x and find whether it divides or not. So let's see exercise 2.3. The first question states that find the remainder of expression x cubed plus 3x square plus 3x plus 1. We have given three conditions. That first, if it is divided by x plus 1, second, it is divided by x minus root 2. In my book it is not printed, so I am just taking root 2. In third, it is given that x minus 1 by 2. In fourth, it is given x plus 5. Fifth I am not taking because you will understand in this. So what's the condition? That let's take this polynomial as fx. So here fx is getting divided by x plus 1. Therefore remainder would be f minus 1, because x plus 1 equals 0 and x equals to minus 1. So let's substitute the value. Minus 1 whole cube plus 3 minus 1 whole square plus 3 into minus 1 plus 1. Now minus 1 plus 3 minus 3 plus 1. So 3 gets cancelled. Minus 1 and plus 1 also gets cancelled. Therefore remainder would be 0. In this fourth question, we have to not take the value of pi, that is 22 by 7, but directly take x is equal to minus pi. And here it's very easy. You have to just write minus pi the whole cube plus 3 pi square plus 3 pi plus 1. In fourth question, it's only there. Now let's see the factor theorem. Factor theorem states that if fx is divided by x minus a and fa equals 0, then x minus a would be factor. Okay, now let's take the proof that here fx is the polynomial, then it is divided by gx, the quotient is qx, and here it is r. It is not divided by gx but x minus a. Therefore here r would be constant because it's a linear polynomial. Because this one is linear, therefore the remainder would be less than this, so r would be linear. So now let's say, and here you know that r equals 0 because fa is remainder. This is just a link from the remainder theorem, because this factor theorem is taken out from the remainder theorem itself. So now let's see that fx equals x minus a into gx plus 0. So now we have not equate anything, it is just already given because this is a basic division theorem, so it is only the proof. We cannot prove this because it is already proved theorem. So let's take exercise 2.4. In exercise 2.4, first question is to examine whether x plus 1 is factor of first x cube plus x squared plus x plus 1. Here I am only just showing the method, I am not doing the all sums. So here by factor theorem it is stated that if, let's take this as x minus a, this as polynomial fx. If fa or remainder would be 0, then the x minus a would be factor of fx. Okay, so by the same condition that x plus 1 is equal to 0, x is equal to minus 1, then if f minus 1 would be 0, then x plus 1 would be its factor. So now let's substitute the value. So here we get minus 1 plus 1 minus 1 plus 1. So it gets 0. Therefore, x plus 1 is factor of x cube plus x square plus x plus 1. Now guys, I am not covering the factorize the cubic polynomials and identities in this video. Stay updated with this channel and I will shortly make the video on that and upload on this. So, hope you guys enjoyed this, and if you have any queries, ask me in comment section, and like, comment, share and subscribe my video. Thank you.